Okay, this video, I think I'm just going to get straight into it. I'm not going to draw the functions. I'm not going to go through the introductory kind of things. I think you can check the previous video out if you don't understand what it is that you are actually doing when you're solving general equations. Okay, for this one, 3.6, let's just get into it. First problem is that you have different functions. There's cos and there's sine. Okay, so that's the first issue. If you have two different trig ratios as you do have here, you can't solve this until they are the same ratio. Okay, so there's a number of things that you will want to look for. Maybe you can change them both to become the same thing. So maybe you can make both of them sine. Maybe you can make both of them cos. Maybe there's options like that, right? Maybe you would want to factorize. So there's a ton of options. This one is also a common one that you will see, where you can see that whatever is inside. Okay, so have a look at this quickly. What's inside this cos and what's inside the sine is the same thing, right? So what's inside cos and inside sine is the same thing. There's one term on both sides. So this one is nice and easy. The thing that we are going to do for this question is to divide both sides with your cos, 2x, right? So you're dividing both sides with your cos. What am I going to accomplish by doing that? If I look at this should look like our that should look like our quotient identity. Quotient identity, something divided by something, that's quotient. And sine divided by cos, we know that that reduces to tan of whatever was inside, and here it was 2x equals what's on our right hand side, that cancels with that, so you are left with 4 divided by 1, which is just 4. Okay, great. So here what we did was, in order to get one trig ratio, we could divide both sides with cos 2x, right? And that gave us tan x. This worked out nicely because the same thing that was inside cos was inside sine. Okay, if there were different things, you can't do this, and there is a question like that that we will maybe at a later stage or in another video deal with. Okay, but for now, because it's the same thing, it's easy enough to just divide both of these with cos of that, creates us tan. Okay, so the next thing that you want to do, the first, we gave ourselves steps in the previous video. The first was to get one trig ratio, we've got that. The next thing was to get rid of our trig ratio. So you want to get rid of tan, you're going to do arctan. So on our left hand side, you're going to have 2x. Right hand side, you're going to have this thing, right? Arctan with a 4 inside, right? And let's see quickly what that's going to give us. Calculator says that 75, 75,9, and this is degrees, right? So this over here is our reference angle. As soon as you have gotten rid of your trig ratio, you have your reference angle. This guy, he is my reference angle. Okay, we're not going to do any manipulation, as we've said in the previous video as well. Once you get rid of tan or your trig ratio, you've got your reference angle. Now we go to our Cartesian plane. Okay, so you have in this one over here tan, and tan is a positive. This is positive. Right, so here you have tan, and you want to see where is tan positive. Tan is positive in this quadrant and in that quadrant. So my solutions are going to exist in first and third. Great, so let's go to the first quadrant. How do you get into first quadrant? 0 plus. Okay, so we'll say 2 theta, or 2x in this case, is equal to 0 plus our 75. So let's just go straight into write that, 96 degrees, and we're adding k times something. Right, now remember in the previous video we said k times 360, but now I'm going to say k times 180. What is the reason that this time I've got k times 180? The reason is because I'm dealing with tan. Right? And our tan function, we haven't drawn it, but we should know that our tan function has a period of 180. What does that mean? That means the tan function repeats itself every 180 degrees. Your sine and cos has a period of 360. It repeats itself every 360 degrees. Tan is 180. So when you're dealing with tan, remember it's k times 180. If you have sine and cos, it's k times 360. Okay, great. What's the next? Let's get rid of the 2. So we're dividing everything with 2. So x is equal to 37,98 degrees plus k times 90. Okay, we need another solution in our third quadrant. That's how do you get into your third quadrant? Third quadrant's over here. 180 is there, so I'm saying 180 plus. So my 2x is going to equal to 180 degrees plus my reference angle. My reference angle is my 75,96 degrees. And again, k times 180. I'm not going to rewrite this because it's already at this question. Right? If it wasn't in this question, then I would need to write it, but it's already there. Okay, so now let's just say 180 plus our reference, which is 75,96, and that's going to give us 255,96 degrees plus k times 180. And the next part is easy enough. Divide everything by your 2 so that x can be on its own. So x is equal to 127,98 degrees plus k times 90. Okay, that's that. Work through these. Okay, this one was a little bit more, well, let's say different to the previous one. When you already had 1:3 ratio, here you had to create 1:3 ratio. We did that by dividing both sides with cos of 2x. We could do that because 2x was in both of them. Okay, but we will have other options. We can reduce it with co-functions, as these can both be changed to each other with 90. I think we will leave that for another video, or sometimes we might even want to do some factorization, which we'll also maybe do in another video. But remember, you need 1:3 ratio. Once you have 1:3 ratio, what do you want? You want to get your reference angle. As soon as you get rid of your 3 ratio, you have your reference angle. Once you have your reference angle, you go to your Cartesian plane, you figure out which quadrant you are in, and then you'll say your value on the side. So this one on the side goes here, right? And then it equals to 0 plus, so 0 minus, 360 plus, 360 minus, 180 plus, 180 minus. One of those things to get into the different Cartesian, well, different quadrant that you need. And then you find your, in this case, 2 solutions.